Yeah, last night's Falcon Heavy launch was a total washout, at least as far as my photo was concerned. I didn't have the
There you
f-stop
go.
closed down enough. There's nothing below 4.
Hey, y'all, it's Dr. Know-It-All. Guess who I'm with again? It's Dr. Scott Walter. We are going to talk about something. This is going to be a bit of a hot take because, of course, I have been busy caring for my family and nobody has had a huge amount of time to look at this anyway. But we're going to look at DeepMind's research paper and their video, which is super cool. So I think I'll start with the video because why not? All right, so here's a tweet from Sergey Levine. This is a DeepMind. It's a Google robot, and Scott and I were just trying to figure out what this guy's name is, but we can't remember. Google does have a name for it. But anyway, the important part of this is not the robot itself, because that was, of course, designed by Google for them to do playing around with things like this. The important part is it says, like, move banana to 3, or move the strawberry into the correct bowl. So you'll see this as we go along. It's the commands are English language, very, very vague and loose, not the kind of thing you ever have had to do with a robot. I mean, you've got how many decades of experience with robotics? This is not the way you talk to a robot, right?
Right, correct. You do not interact this way. You would do things with a lot more precision and be way more mathematical.
Yes.
Oops.
Yeah.
Yep.
He's not the most he's a little bit clumsy. So, but yeah, but anyway, so everything's 2x speed, so it's a little bit slower. And of course, the gripper is not the most dexterous thing in the world. So, oh,
Correct.
wait, notice they have a 3, an X, and a Y. Did you see that? I didn't even notice that till now. That was
Oh,
that
really?
was a little dig at Tesla, I think. Here, wait a
Oh,
second. Let me go
wow.
back to this. Let me go back. Yeah, there's definitely, if they had an S in that picture,
Huh.
I think that was a dig at Tesla. So yeah, pretty wild. Anyway, so but the basic deal here, this video is showing, and we're going to look at the research paper, is that I love how he's just really not the most dexterous robot in the world, but he's basically, you're giving it natural English language commands as you would give to another human being. Move banana to Germany, which that's a really crazy one, because think about the context you have to be able to get. I think you mentioned something when we were talking earlier, like, do you have to like box it up and ship it to Germany or something? And it
Yep.
understood that it just needed to move it to the German flag instead, which is very impressive. So yeah, let's see. I think there's one more. Yeah. The chip bag that is falling. Oh no.
Whoops. Yep.
So a little bit of a goofy situation. But so yeah, so that is the video. And then of course there's a research paper. And I don't know if you want to show that, or you can show that if you want.
It should be this paper right here. And if you go to that tweet,
Yes.
you will also be able to find this paper.
Right. And of course I'll put a link to that stuff, in the description so
Yeah.
people can look at it themselves.
So I guess we can see everything here. So it's RT2, which is not like a new Rivian model, but it's the robotic transformer 2.
Yes.
Um, and of course, we shouldn't be surprised that the T stands for transformer and the R for robotic.
Right.
And you see, it's a novel vision language action model, or
Right.
VLA. And this is an interesting part here, is that it learns from both web and robotics data and translates this knowledge into a generalized instructions for robotic control. So
Right.
it's a rather, I guess, sort of novel architecture, and I think it's very interesting in how they were able to get to the results the way they did, almost inverted from what we were expecting. Somewhere down here, they mentioned they first start out with a lot of real world teaching data for the robots. So it's almost like they primed the neural network to some level to actually be able to control the robot.
Right.
And then they start teaching it the web data and then improve it from there.
Right.
Or with simulation data and everything else. And a lot of times I thought, oh, it'd be the other way around. Is like you simulate all this stuff and then you start letting it loose in the real world.
Right.
And it also sounds like the amount of real world interaction that they needed was not that much.
Yes.
It's still a lot, but I think it was 13 robots over like 17 months or something like that, doing some things in the kitchen.
Right.
So I guess we go along here. So this is pretty much the abstract.
Oh, well, actually,
And
before
yeah,
we do that, scroll back up to the boldface title of So
yep,
vision language action model, that, like, just to wrap people's heads around that, of course, is Vision, obviously vision. It's also got LiDAR. You can see the little LiDAR thing spinning. And then language is pretty much, I assume well, it's not ChatGPT, obviously, but I can't remember what language model they used. But it's one of the large language models like people have become used to in the
Was it
past.
Palm, I think?
Yeah, I think, well, that makes sense since that's
Yep.
DeepMind's thing. But anyway, so it's a large language model that you can interact with on the web, right? You can ask it questions and it can respond. So that would be like English or French or whatever. You can interact with it that way. And then the last step, of course, is that it actually outputs actions. It does actions and it apparently tokenizes those actions and then is able to iterate over that. And to your credit, Scott, I remember in a video pretty recently that you were like, yeah, this is the way this should go, is it should be outputting tokenized versions of actions that makes a sentence of what it does. And so
Well, it makes
really
sense. Yep.
cool. You were right there. Like you were calling it, man. So yeah. So anyway, continue on. I just wanted to make sure for people who are like, what the hell is a VLA? You know, they have some idea.
Yeah, and part of the thing here is, they talk about is it is able to operate across different languages, so that you can give it
Yeah.
prompts in different languages, and then it will internalize that into whatever is needed to be able to create the actions that it has to do.
Right.
And um, yeah, let's go to. I mean,
It is
there's a lot of
interesting
things that
that
are
a
great.
lot of the scale that they got was from web. And it's unknown whether I don't know if they're talking about like looking at YouTube videos or
That's what it seemed like. They were talking
yeah,
about using a lot of YouTube videos, which
right,
was rather remarkable, that
right.
they were able to do that.
Yeah.
And I think, one of the things that kind of jumped out at me looking here is that they were incorporating this chain of thought reasoning,
Yes.
and which allows it to perform multi-stage semantic reasoning.
Right.
So
And that's
it's
also probably worth calling out really quickly is
yes,
chain of thought. Um, LangChain, if people may have heard of that or potentially used it, or um, there's prompts for like ChatGPT and stuff where you can say, "Show me your steps," right? Basically, show me your homework. So it's the idea of it having to not just give you an answer, but give you all the steps in the answer. And then what you can do with that chain of reasoning is there can be either from a human or the robot or whatever. It can be like that's close, but it's not quite right. Can you iterate on that and try to make it better? And the deal, of course, is that that's the way we work. Whether or not it's like writing an essay and you write the first draft and you're like, oh, the introduction sucks and I need to redo it again or something, or picking up an object, you're like, oh, I missed
hmm
by a little bit, and you're course correct as you're reaching out for that object or something, whatever that is.
right.
Yeah, the chain of thought reasoning is really, really critical. It's the kind of, again, I think the best way is just show me your homework. It's like, don't just give me the answer. I remember my kids were always like, oh yeah, I'll just give them the answer for my math homework or something. It's like, no, they want to see the steps. That's how they know that you did it right. So so anyway, that's the kind of thing it's doing, but it's doing it in motion, not just
One of the things that I was going to ask you about is, based on this, whether it was doing a certain amount of reasoning, and it says so right here in the text, that
right.
it is doing reasoning. So you give it the prompt of what you want to do, it understands the context, and then it may have to make some sort of decisions based on what it sees in there. And that was, part of what we talked about is like, move the banana to Germany. In that case,
Yes.
it's pretty clear you meant to the German flag, which would
Yes.
have been, let's say, more correct to say move it to the German flag. Germany means a country, so you would think, oh, that means I have to box it up and ship it out.
Right.
And then they also talked about a lot of emergent behavior, which I wasn't surprised. And one of the examples that's here, they see a little bit further down in there, like deciding which object could be used as an improvised hammer, a rock. In other words, it knows how to MacGyver something, a particular situation to get the desired result. And that there is like, wow, that's rather interesting, but could also be a little bit scary that it
Right.
can do things like that.
Actually, so do we need, instead of LLMs, we need LMMs, large MacGyver models?
Yeah, exactly. So it definitely is MacGyvering
Yeah.
a lot of cases there. And then again, is like, the vagueness when you say something like, put the apple on the table.
Yes.
Usually, when we do that in a standard robotic situation, we're talking about a specific point in space that's well
Yes.
known with precision. And we need to know that. So we can't proceed ahead until you tell me, well, where on the table do you want it to have? In this case, it doesn't care. So long as it's anywhere on the table, that's all that matters.
Yeah.
And so it will probably have that freedom of choice of where's the easiest place to put it.
Yeah.
Maybe it's going to decide to put it dead center, or just so long as it's touching it, that's good enough. It's accomplished the task. So it's rather interesting to see that you can be so vague, and yet it still is able to come up with a set of instructions and perform that task.
Right. Oh, interesting. Okay, oh, hold on. Before you keep going, notice that they say we successfully trained on web scale data, which is again probably million, tens of millions to billions of pictures and things like that, to perform tasks like visual question answering, which means that you look at a picture and say, "What's in this picture?" or "What's going on?" or something.
Mhm.
Object recognition, image capturing. So basically, they're teaching it through that to understand the world. They're like,
Right.
this is how you're going to be able to visually, but it's remarkable because of course those are two-dimensional images, not a three-dimensional thing. So it's really
Mhm.
cool that it's able to transfer that knowledge from just 2D pictures. It doesn't even look like they necessarily used video. It might have just been still
Yeah,
from.
it might have been a combination of everything.
Yeah,
So, you would see a lot of examples of flags. So, oh, you know what the American flag looks like and the German flag looks like. So it would recognize that.
right.
Um, and it's setting up its own internal description of the world as a set of natural language tokens. So it's
Yeah,
you've got this tokenizer down here. It's not surprising. And they even talk about the representation of an action ends up being a string. And
right.
this is what we were sort of speculating would be a
Yes.
potential approach to take to these problems is to tokenize all your movements in some particular way.
So
And this
I
case is maybe a bit lower level in that they're really getting down to kinds of actual Cartesian positions or how much to adjust or move something. But there
right.
could be something a little bit higher up, which is the idea of moving towards a particular object, and then you've got to break it down and what are the steps I have to do to get to that object. But the
Exactly.
first thing is getting a sense of that, and then
Right.
of course what the gripper state's going to be able to accomplish that.
Right. And just a couple of things. Number one, Palm E is, I believe, what powers Bard, if I'm not mistaken, or at least some version of it. So
Hmm.
that's something that you can interact with if you just go on google.com/Bard or whatever. So that's pretty cool. Number two is that again, we're tokenizing. A token is basically a word. That's not quite right. Again, if you think about the word like walking, you would have the word walk, and then ing would likely be two tokens. So tokens are pieces of words, but you can think of it as words. And then the output is tokenized into action words, quote unquote. Right.
Right, and
Those tokens.
they kind of say right here that they're representing actions as tokens in
Yes.
the model's output,
Right.
similar to language tokens.
Right. Right.
So kind of like what you just described. That it's like
Yeah,
it's close.
it's if you think about it, of course, it's a little less linear because here you've got something like the arm and the gripper and everything are probably happening in parallel. Although it looks like
Mhm.
they've got it in a linear fashion. It figures out where to go in X, where to go in Y, where to go in Z, and then it does it a rotation. So it's doing like
Yeah,
six
and what's
steps.
interesting here is that it's going delta XYZ.
Exactly.
So it's not giving you an absolute position.
No,
It's
no,
sort of
no.
the change in your current position to get to where we want to go.
Yeah.
And that's what's very important here is that you're sort of planning what are the steps I have to do along the pathway.
Right.
So one example I'm thinking of is like I want you to go up on the roof, so you've got to go up the ladder. Well, the
Yes.
ladder is made up of a series of steps,
Yes.
and you don't think about the top rung. You think about the first rung.
Right.
What is that delta position you have to do? And when you
Right.
do that, you check to make sure is is there terminate or continue state there.
Yes.
So if that rung is okay, it's able to hold my weight, I go to the next one, the next one, the next one.
Right.
And am I starting to lose my balance? Is one of the rungs breaking? Is it getting kind of windy? Is it a little bit slippery? Then you might determine, say, all right, terminate. So
Terminate.
every single step of the way before you get to your destination.
Right.
So it's a
Or
long-term planning.
alternatively, of
Yeah.
course, alternatively, I've reached the top of the ladder, so terminate. So,
Yeah, that would be the terminate when you finally meet the goal. But along the way, there may be a reason to terminate because something is amiss with the actions that's going on, or it's deviating from your plan.
yes.
So again, when we are driving or walking or doing anything, we are forecasting 10 to 20 seconds into the future
Right.
on what our expectations are of what's about to follow. And so long as it continues to follow the way we planned, we're happy. But if something is different than what we were expecting, that's when we know we have to terminate whatever the action plan we have right now and come up with something completely different.
Right. Right.
Reassess and reevaluate. Yep.
But anyway, I mean, it's really cool here, and it's not just when you look at that little example thing they've got there, that would be repeated hundreds of times on the way to picking up the banana
Mhm.
or whatever it is.
Yes.
Yeah, it's
Yes.
not just one
Um,
of
uh,
those. That's why the deltas are going to be very small distances and rotation.
And we were seeing as it was going for, some of the fruit that sometimes it was sort of struggling to get there. And
Right.
almost it looked like that its elbow might have bumped the table or something.
Yeah.
And then it's like, oh, something's wrong here. I have to adjust to try to get over there. And sometimes it's really stretching to go ahead and get it. So it doesn't really know till it tries.
Right.
Here are like some examples of some actions. We can see that it's both in English and in French. So the idea is it doesn't just have to be in English. So any sort of input language could be used. But the idea is the result is the same
Oh.
output.
Oh, it's saying you're making a cake. That's cool.
Yeah, yeah, yes.
Um,
And yeah, so then it figures out what the task should be, and it just breaks it down into these delta translations and rotations, how much it has to do to start getting in that direction.
right.
And so that would be sort of the closed loop for the control to be able to look at what's going on, making sure it's all right. And then of course, some failure, picking up a nearby bag which is falling down, and then like, oops, what do I do now? A reattempt. So sometimes it couldn't quite grasp the object right, and this is just showing that they're still very early on.
Yeah.
Eventually, the bot will be smart enough to know that that's the wrong way to pick up the bag, just because of the type of grippers that you have. So
Right.
you really need to rotate the gripper about 90 degrees to be able to grab the bag that way. And that's something that will come with lots and lots of training data. But
Yes.
right now, it's just, whoops, that's a mistake, because that's not how you're supposed to pick up a bag of crisp or whatever that is there.
But I mean, even at this stage right now, it's pretty remarkable that they were able to get the scale of training just from looking at pictures and things. It's just
Yeah.
very impressive.
Yeah.
But it's really cool because it's like, what should the robot do? Task, right? Should it's just very cool that it just translates that into what we would consider mathematically, just like small variations. It's like, go 0.1, negative 0.2, and 0, and rotate this amount. So it's just very cool that it's
Right.
doing.
And the question with the reasoning, and then you're very vague and whether you're very precise in what you're talking about or
Yeah.
sort of imprecise. So if I say, go get the beer versus go get a beer,
Yes.
one is the definite article and one's the indefinite, in
Right.
which case it's sort of free to choose whichever one if you just say go get a beer.
Yeah.
But if it's then it's got to sort of back up a little bit and say, oh, okay, that might be referring to something we were talking about in a previous sentence, right?
Right.
Or there's something in the room. There's only one there, but at that point, the language model might want to come back and question and say, well, wait a minute, your query here or your request, I can't quite satisfy it because I don't know which one you're talking about. There's a variety over here.
Right. Right.
But I think it talked about somewhere later up this idea of it doing a certain amount of reasoning. It had something to do with grabbing a drink and realizing, well, the person is tired, so I'm going to get them the Red Bull.
Yes.
So associating certain drinks with a certain state that someone's in. So it may be that, well, I know enough about the person that when they say that, I know specifically what they are referring to just because
Right.
that's in my database somehow.
And
So that's going to be really interesting to see how that reasoning goes ahead.
yeah, and it's really interesting to think about how eventually something like this can be so easily integrated into a conversation. Just like with a person, you're sitting in the living room and you say, "Man, I'm super tired. I need a drink." And the other person in the living room would have the context of that within the conversation and go like, "Let me go and get you, yeah, like a Red Bull or something." Yeah, they would
Yeah, or
know
a cup of
what
coffee or
yeah,
tea or like,
yeah, whatever. So yeah.
yeah,
And also even to the point where if eventually, of course, these robots, if they're in your house, could learn what you want. When you say you're tired and thirsty, do you want a Red Bull or tea or coffee? What is the thing that you're most likely to want?
right, right.
Yeah.
Because houses are made up of coffee drinkers and tea drinkers.
Yeah.
Um,
And Red
and
Bull
some
drinkers.
people, yeah, and then like some houses like, no, we don't want that. Uh,
Yeah.
but this was interesting here. I was expecting this that they would end up getting some emergent behavior, and sure
Mhm.
enough, they did. So generalization, emergent behavior. So it's able to do tasks that were not in its database. So it had never, basically scenarios never seen in the robotic database.
Right.
And it required knowledge to translate from web-based data to operate. So it pretty much was shown. It already knew how to, I guess, 6,000 robotic trials
Right.
was what they're able to do over 17 months. And so that was clearly in the database that we knew how to do it. But now we're suddenly throwing a curveball at it by showing it objects it's never seen before, or
Right.
some kind of mixture of tasks it's never seen before. This one here, I think, is interesting. We saw in the video, put strawberries in the correct bowl.
Right.
And And think about it. So there's a bit of reasoning there. You get three bowls
Right.
with different fruits in it, and one of the bowls already has a couple of strawberries in there. So that's all the hint that you need.
Yes.
And the fact I can figure that out is it's rather amazing. And then I think there was also some other objects I had not seen before, others that were very similar, but some of them that weren't there, and it somehow was able to figure out, probably because it's seen it in the web, of what the type of ball was or what the type of shape was that was not
Right.
clearly there before.
The one with the strawberry is really interesting too, because correct is an interpretable outcome. Maybe
Yeah,
maybe in my mind, the correct bowl is the peach, the one with the peaches in it, because you wanted strawberry. It's just really interesting that it's able to
right, right.
reason out something like that.
But
If you say
yeah,
put
what
it in the bowl with the other strawberries, that's a much more direct command. That
Yeah,
requires
and what if you have one of your kids' bowls there, the strawberry shortcake bowl,
yeah,
but it
yeah,
doesn't have any strawberries in it. It's got some oranges, and then another white bowl there that just has one strawberry. And it's like, oh, okay, which one's the correct one?
yeah. Just it's just fascinating how loose they are being with language and how well it's doing. So and the bottom right, I don't think we saw that in the video, but pick up the land animal. So it has to, I mean, that is a lot of reasoning
Oh,
steps.
wow,
It has to go
yeah,
through that and think about what is this? It looks like there's an octopus in one, and so it's like, okay, octopus, oh, that lives in the ocean. And then there's something four-legged there. I don't know what it is, but anyway, that it has to rationalize through what it means and then what would a land animal look like. That's a lot of steps of reasoning.
and then go ahead and do it. And it's quite interesting to see that they've been able to pull something like this off.
Yeah,
And now this robot that you have, it'd be very easy to throw a lot of shade on the robot to say it's not a real humanoid robot, does can't walk, and that's the whole point.
yeah,
They weren't really worrying about coming up with a bot that's a humanoid bot. It just had to have certain characteristics to allow them to move ahead with this language model to test out these theories. So
yeah,
the hand is a gripper, is as simple as possible. They don't care about dexterity. They've got a robotic arm, which is sort of like a human arm as far as the number of degrees of freedom, but some funky offsets in there. But it has, let's say, a pretty long reach, much longer reach than a typical arm.
right.
It does have a head for the vision system in there, and it's a mobile device, so they don't worry about walking. One arm is good enough, and just having a gripper that can grasp, so it can do all the very basic things that you need. So rather than spending your time and coming up with a super deluxe piece of hardware to test this out on, they came up with like really the bare minimum to go through and now start training these language models, because that is really their specialty and that's what they're trying to do. And I
Yeah,
think they've made some rather remarkable progress right there, because we've talked about that triad. There's the dexterity, coming up with a good hand model. There's the
right.
ability to walk, and then there's the brain.
Yeah,
And the keystone to the whole thing has always been the brain.
yeah. And this robot, for people who don't know, it doesn't have legs, but it has wheels, so it can move itself around. It,
Yes,
it does have.
yes, yes, exactly. So it is mobile. It's only going to be on flat surfaces and stuff like that. But you don't worry about the balance problem and all the other things you have to go into actually having legs. All that's important is that it has the concept that in order to get something, I have to move over to there.
Right,
It's so when you go to grab something, you have to make a couple of decisions. One, is it within my reach?
right.
And what do I have to do to reach it? Is it like some very minor adjustments I can do with my body, just twisting my body, or do I actually have to sort of walk towards it or lean into it or something like that? So you have to have this concept of things being kind of near or far away, and being able to decide when and whether you need a combination of both the mobility and the movement of your arm, or whether you can just keep your base completely fixed at that time.
Right.
So you want that to be part of the behavior of whatever the device you have. Whether it then learns to walk, you don't care. It just, so long as it has the concept of mobility.
Right. So one interesting thing, and maybe they have it in here again. This is a relatively hot take on this, but it it was unclear to me whether it was generating each movement. So think about it like ChatGPT. It generates a word and then it generates another word based on the last word and another word based on the last word. I don't know whether it's making the movements and then reevaluating and then figuring out the next one, or whether it does the entire shot of what it's going to do in one thing and then moves through those. So in other words, does it generate the sentence it needs to move itself and then move, or does it move a little bit and then reevaluate and move a little bit and reevaluate and move a little bit? Because in that case, it can iteratively get better as it
Right,
tries to
right. I,
move.
I, I would think maybe it's a little bit of both.
Yeah,
That the first thing is you put out the entire plan. This is how I'm going to do it. And then you take each section of that plan and you start to execute it.
Yeah.
And then make sure that you're able to do that and move on to the next. It's probably no different than when we plan a long trip. We go ahead and put in and we know what
Right.
all our stops are.
Right.
And that's what we want to do. We want to try to stick to that plan as much as possible. But as we're going along, there's something like, oh, detour needed. And the
Right.
whole idea is that we want to try to come around and get ourselves back on route.
Right.
Or, oh, we've got to stop a little bit earlier to hit a restroom, or I'm not going to say fill up gas, charge or whatever.
Right.
So those things may be a little bit different as far as the nuances on how to execute certain sections of that plan, but you're always trying to get back on it. So I would think it does have a big idea, and then at the low level is trying to execute them as best as it can.
Right.
And then it probably has to evaluate it. At some point, it might be, well, we really can't get there because this particular subtask just completely failed. I need to pick up the object. I dropped the object.
Right.
That's it. It's over. There's no need to continue.
Right. But it also goes to show we shouldn't underestimate the power of the vision system too, because the robots that you deal with in general are blind, right? Your
Mhm.
big industrial robots, if the thing isn't where it expects it's either going to stop or it's going to pick up air and just,
Right.
whoops, I missed it. And here you've got this robot is clearly very different and it's using its vision system to understand the world, but then also to be able to evaluate how to move through the world, which is also very important.
Yes. And yeah, that's the thing of having a vision system that actually understands the objects are there and how to come up with a plan to get there.
Right.
And this could be really interesting, whether it's heuristically based or whether it's just a neural net. Because in traditional robotics, your vision system is using it to plan some kind of Cartesian location.
Right.
And you're usually picking up certain groups of objects that you already are very familiar with. So
Right.
there's not going to be anything that you don't know. So you come in and you identify a particular object, you identify the location of it, you calculate the position and go after it. So
Right.
it can all be done very heuristically, and there is no imagination, there's no creativity, nothing going on. Whereas in this case, it's like, oh, I see this object. I'm just going to now kind of go over and get to it. And how it's planning that task, I don't know. Is there some point it's going after that it's imagining? So when we go to grab a bottle, like we can see the ketchup and mustard bottles that are down there. When we go to grab it with our hands, I guess we're kind of aiming towards the middle of the bottle. So we imagine a center point in the middle of our hands, and we're trying to overlay the two to say that's what we need to do to grab it. So imagine it might be doing the same thing. Is it? We really don't try to grab it by the lid or anything like that, because we know from experience it's not going to be a very stable pick.
Right.
We're going to lose our grasp right there. So I
Right.
kind of wonder if it's doing that. And again, what kind of error is considered acceptable? In a sense, quite a lot. I mean, we probably are taking up a lot more error than we expect when we go to grab a bottle. All that
Right.
matters is that our hands are able to kind of center around it. And then as we close our hand around it, our fingers and everything will make up for whatever error we have. And whether you're a little high in the bottle or a little bit low in the bottle doesn't matter. So
Right.
you've got a fair degree of slop that you're allowed to have in there, and it will still work.
Yeah.
So many of these real world tasks really don't require a whole lot of precision.
Right. And I was thinking about like some things when you're doing like high level athletics or something like that where it actually does the precision is super important, but but that's relatively small cases of things in the world. Most of what we do is pretty sloppy. We can get away with an awful lot of
Hmm. Because there's
flexibility.
compliance in the model.
Exactly.
we
Exactly.
have we have a lot of compliance that allows it, whereas most industrial robots are very stiff,
Right.
and so they don't have compliance. And it's ironic, sometimes they will throw compliance in there. I've seen these examples where you need to deburr holes, and so you have a robotic manipulator coming over with a very big deburring end, which is basically a conical piece that goes into a hole.
Right.
And when it goes down into that thing, you're just basically trying to deburr it and get a few things out. You might
Right.
be off a little bit, but as you push it in, the head itself has a certain amount of compliance that allows
Yeah.
it to kind of slip around to where it's supposed
Right.
to be, because the arm itself won't do it. Now, cobotic arms are a little bit different in that
Yeah.
their compliance is actually in the joints. So when you go to put it in there, it sort of forces the arm to adjust itself to get it to match
Right.
the way you want it to be. So yeah, the world is actually very sloppy, and with compliance, you can you can solve a lot of issues.
Right. Wait, go back up just a sec before you leave that. The graph that's there. This is
Mhm.
interesting. It's worth calling out because the RT2, there's two of them, the purple and the teal colors, and the bottom one, the teal color, is the Poly X, which is specifically designed for motion and everything. And if you look at that, the Palm E, which is just a text-based one, actually outperforms it in most circumstances. And the two
Hmm.
of them, the average, unseen task overall average, they're just dead even. And
Yeah.
that's pretty cool that a large language model basically that's been modified is actually able to compete with something that was designed for emotion. So very, very
Yeah,
interesting.
which is rather remarkable, and I think a few months ago, I remember hearing people discussing that and wondering whether they could do something like that, and
Right.
some thought, well, we don't think it can. Well, now I think we've answered the question. Looks like it can.
Looks like we have an answer to our question here. And remember, this is alpha version of this stuff. This is going to evolve pretty quickly and it will get better. So, yep.
Yeah, and then I think this was also one point here that the fine tuning,
Yes.
with just a few hundred gradient steps. So that sounds like it was actually very easy to teach.
Yeah, actually, that's wild. Um to it. Yeah, okay, here we get into the augmentation. So they augmented the
Mhm.
data to include an additional plan step. This is where the chain of thought thing comes in.
Yep.
First describing the purpose of the action, followed by the action and the action tokens. So it's a chain of thought. It's like, what is the purpose of the action to move the banana to the 3 or whatever that I can't remember what anyway, but to move the banana to this spot. And then it says the action, which is, well, I'm going to move my arm, I'm going to go over here, pick up the banana, and I'm going to move the banana over there on top of that number. So that would be the next step. So there's chain of thought, super abstract, medium abstract, and then the last part is the action tokens, which is, delta X my arm this distance, delta X my arm this distance. So it's like, then that's the long sentence or paragraphs of
Right.
information needed to make it actually do that motion. So
Yep.
really, really
A-
cool.
Yeah, and then we have, like, again, this sort of example of the MacGyver. The
Yeah.
question is, or the instruction is, I need a hammer. I need a hammer nail. What object in the scene might be useful?
Right.
And then the prediction, the rocks. And
Right.
then the action to go ahead and grab it.
Yeah.
And yeah, how, have you ever had to nail something with a rock?
Yeah. I have once in a while, or at least things like it.
All the time, out in the woods, you're camping or something like
Yeah,
that.
no, it's like tent
Maybe
stakes.
it's for
Tent
putting up the
stakes.
tent stakes
Yeah,
for
and
sure.
tent
But
stakes are the ultimate answer to that because it's
every
always
now and then you actually have to
accidental.
put something together and there is no nail. And then you're looking for the rock.
Yeah. So there you go.
And usually ends up with, like, a broken thumb in there somewhere along the
Yeah.
way. You
Or
screw up,
or almost inevitably the tent stakes get bent because
Yeah,
it's
the
not
tent
accurate
stakes.
enough.
And
It just
yes.
bends the tent stake. So yeah. Um yeah, and so then we have the conclusion down there, like we've done some pretty good stuff. So the Palm E and Poly X RT2 results in highly improved OBS. So both of them are really, really good. And it's interesting that they're competitive with each other and very similar in performance too. So very,
Yes.
very interesting. Um, but yeah, and then the last paragraph, the promise to build a general purpose physical robot that can reason, problem solve, and interpret information for performing a diverse range of tasks in the real world. That says it all basically. It's
Right.
that's why
Because
this is so impressive.
if you can get that emergent behavior,
Yeah,
then that means it can start to reason and do a lot of things in the real world,
yeah,
even though it was not taught that task. It's
right,
just a question of how much does it need to know to be able to start doing that.
right.
And of course, it will always run up into a brick wall every now and then, not know how to do something because it's way outside of whatever the set is that of information that it needs.
Yeah.
Then you just keep on training it more and more and more things.
But this is, we do have the out of distribution thing. So I think that let me hold on. I was going to try to stop sharing for you. There we go. We do have it's really good with out of distribution, which means that it's stuff that it hasn't trained on before. But the last thing I want to touch on here, because this is just so cool, but do you think, we've gotten a lot of information from Tesla recently, and they've talked mostly about their cars, but it seems like it's even more important for Optimus, for the Tesla bot. do you think that the Tesla is onto something like this at the same time too? That this is part of their end-to-end training? There's I feel like there's been a lot of indications that they are
I know
moving.
the answer to your question, John.
Okay.
Ask the Tesla AI.
Well, the problem is I can't right now. It doesn't have a voice
Or
interface.
no, it wasn't Elon said, now ask the
Oh,
Tesla AI.
oh, there you go. You're right. So there we go. Yeah, I see. I was thinking to myself, I was like, yeah, obviously. And he was like, it's so simple. The answer was obvious. Look at how simple conceptually what's going on with the RT2 is. It's like you tell it what you want, it does a planning stage, it then refines that down to a generalized action stage, and then it refines it down to a millisecond by millisecond, or whatever it is. However small you want to break that up into. And if you can do that in real time at 30 or 40 frames per second, damn. That's
Yeah. Yeah.
and
Yeah.
and especially if it's able to make these plans and then update those. So you do a couple of them and then you reevaluate and you're like, whoops, starting to drift off the road or something, or not going towards the object I'm trying to reach. Adjust. So you can be
Make
doing
course
this.
corrections.
Yeah,
Yep. That's how a control system works, is
yeah,
that you have a planned trajectory and then you try to execute that. And
right.
if you deviate from that path too much, you try to figure out, what do I have to do to come back? And that's sort of the idea of the negative feedback, that you try to go ahead and bring yourself back into the course. As the error gets too big, you got to go in the opposite direction that you've been heading to try to correct yourself.
Right. And
And
I'm sure if people have used, especially older robotics and stuff, or maybe if you've just driven an RC card when you were a kid, that overcorrection thing where the classic wobble where it was like
you're
overcorrect,
you're
overcorrect,
yeah,
overcorrect,
yeah,
overcorrect.
you're
Yeah.
you're a PID controller with really low grains. It
Yeah.
just no damping whatsoever in there. Yeah.
Right.
So that's sort of the example. And then we we've been talking about the fact that Tesla would probably be able to develop their own large language model.
Right.
And I think Elon just came right out and said it when
Yeah.
he kind of, his remark to Stephen Mark Ryan is like, now ask the Tesla AI. It's like, oh, they must have a large language model,
Right. Well, I
because
think,
pretty much anyone can build one now. So they
yeah.
probably have that. And this might explain another thing, is that I think I was a bit disappointed that when Elon said that, and they only have like 10 bots. I
Right.
thought, wow, I need a lot more to get the training data.
Right.
But maybe it turns out it doesn't. I mean, looking at this paper, it seems that it could probably be a small number. That's all you need to bootstrap it. And
Yes.
then maybe starting to look at like a lot of examples that are in the web, or maybe, actually examples of operators going ahead and doing it, is more than enough.
Right.
So they could be far more along on the AI than we're kind of aware of,
Yes.
especially if whatever version 12 is doing, is that maybe that's the same breakthrough that will also work for Optimus.
Right. Yeah, and remember that Elon said it was mind-blowing, version 12. He said he was driving the alpha around. So at some point, it's obvious that what we're driving right now, the version of this full self-driving architecture, is going to be scrapped. And we're going to look back on it as some sort of primitive, like
It's quaint.
caveman world, like full self-driving. And we'll be like, oh my gosh, I can't believe we were driving around in something that was that primitive. And this is so much better. So it's
Yeah,
going to be a big
and
change.
it's, you sort of wonder, how quickly they're coming out, because I've got plenty of edge cases that I'm sort of trying to document or at least jot down.
Right.
And I'm wondering, like, okay, what's the point of doing it? Is it something that I'm hoping the AI team like looks at and says, oh yeah, we'll get on it and try to fix that problem, or is it more or less that when the next release comes out, I know, oh, I have to go through and make sure that these things have been fixed. It might be more for me to know that, oh yes, it's solved all these things.
Right.
So again, it may almost be like a waste of time to document all these things and say, yeah, we're just going to get it. Because like, don't worry, they're way beyond it.
Yeah, that's what I'm thinking. And a lot of people are like, why don't they fix the stop sign issue or the lane merge issue or these things? It's like, I think they're so far beyond that at this point that it's a stupid waste of energy on their part to
Hmm.
try to go
Hmm.
back and fix something that is a primitive architecture that they're not using anymore. So
Yeah, it's like trying to fix leaks in a house where the plumbing was just installed wrong to begin with.
mhm,
You may as well just tear it out and redo it, or tear down the whole. And so that's kind of like James' analogy. He keeps on
yeah,
talking about how it's the foundation, and so
right.
they keep on building these foundations and realize that up Tower of Pisa over here.
Right.
There's not much we can do.
I
So
think with the with the
let's go over
plumbing
and build a
with
new
the plumbing
foundation.
analogy in my flood, it's like
Oh,
they've got
sorry about
lead
that.
lined they've got lead lined plumbing, and they're worried about patching the leaks, and it's like, no, you got to rip the lead line stuff out and put in some PVC or something. It's like, no, we got
Exactly.
to redo this.
Exactly. Yeah. And that's the weird thing about when I learned that we still have lead pipes in this country.
Oh yeah.
And I thought we learned something from the Romans. And it's like, oh, no, you just put like the right kind of softener into the water. And it basically has like arterial sclerosis on there. You create this coating on the inside of your lead pipes that prevents the lead from leaching out. It's like, and it all comes down to the balance of the chemicals in your water. And if
Right.
for some reason you have a financially distressed water system and they decide not to spend $100,000 on this special kind of softener to put in there that will maintain it,
Right.
once the pH goes off, that lining gets ripped out and everything. And so to me, it's like, man, it's like that is a house of cards. You don't want to build it that way. Just get rid of the lead to begin with.
Exactly.
And the only
Exactly.
reason is because what's the advantage of lead pipes? Oh, it's so easy to bend, you know?
Oh
You just
yeah.
like
I mean,
get it
they're
around.
amazing. It's like
Oh, it's
it's so
absolutely amazing.
malleable.
Like, yeah, really malleable, but that's
So
crazy.
but this just shows you, governments are like businesses. Most of them are going to be like, we'll just keep iterating because it's going to cost us less money right now. Tesla's like, yeah, we just spent $1 billion working on this architecture and all these paying these people and getting this stuff set up. Throw it away. Let's start on this
Yeah,
new one.
yeah. Well, it's a lot easier to tear down, I guess, a software foundation than something that
Yes,
poured
obviously.
concrete.
Yeah.
You're looking at that, but then again, I guess SpaceX does that all the time and everywhere else. And you see that in history a lot of times. They'll pour a foundation, realize it's all wrong, come on, tear it down, and
Yeah.
because that's just what you have to do sometimes because you either you own the mistake and then just move ahead. So
Well, I mean,
more than
look
likely,
at look
if
at Teslas.
version
They
12 is
they
going to be
went
very
from
different.
they went from the standard construction method of like 25 different parts with a billion spot welds all over the place to like stamp it and just bam. And
Hmm.
that was an incredibly expensive and risky move on their part.
Yeah, yeah.
Nobody knew if it would work at that scale. So, you know,
Probably except Sandy Monroe because he'd been talking about that for
yeah.
such a long time. But yeah, a lot of it is because everyone's really afraid of taking that big risk.
Yes.
It's so much easier to just kind of stick with the flow,
Yeah.
not rock the boat, and yeah, I mean, I guess you could also say there's a lot of other special interests that if you get rid of that, you're getting rid of everyone that's in the that section of the body shop.
Right. Right.
So that part of the organization is sort of not needed anymore. And then all the sub suppliers that are working in it
Right.
delivering those things. So there's a lot of incentives for a lot of people to say, nah, that'll never work. You don't want to do it.
Yeah.
They could look, they eliminated hundreds of bots.
Yeah. And a lot of people on the line doing those jobs too. So,
Yeah, and that's a lot of future engineering work. So for every body that comes out, you've got to have someone engineer all that, and that
right.
is a lot of contract work.
Right.
That a lot of robots, a lot of end of arm tooling, a lot of fixturing, a lot of the programming that goes in there. It's tremendous what kind of goes on. So you could see all those would be sort of an entrenched special interest or almost lobby within an organization to say, what? Wait a minute, they want to eliminate my department? Nope, can't have that.
I don't know if you saw the oh, what was her name? She did a whole thing like kind of an inside out look at Twitter and how any project, so this was software, right? Which
Yeah.
but there were so many special interests, and it took so ooh, we got a thunderstorm coming up here in the Andes. There's so many special interests. It took so long to do anything, even a relatively minor upgrade to the software, and it was built on such a house of cards that they would spend 6 months and a lot of money building something and then be too afraid to actually implement it because they're like, we don't know, or else some group of people would say like, wait, I'm out of a job if you do that. So they would give
Right.
it.
Or you're stepping on my toes, or
Yeah. Yeah.
that's my area of specialties. Especially
So
you're not
there's
supposed to
a
be
type
there.
of brutality that you see in SpaceX and in Tesla, and I assume in XAI and other places where Elon's in control. And like a human level one, right? Because it's like, well, sorry, you're out of a job. That's tough, but we don't need you anymore. But there's also a technological brutality. It's like we've just spent all this money building this factory and all these robots and installing them. And it's like, nah, tear them out. It's just like it's just crazy.
Remember the carbon fiber tanks?
Yeah.
for what was then called BFF.
Right.
And it was all that
BFR.
money that was going into those mandrels and being able to spin
Right.
that and
Yeah.
the autoclaves and everything, and a couple of them that they were building, and that was what they were staking the whole future of it on.
Yeah.
And then suddenly overnight they just changed,
Yeah.
and like that whole group is like, we don't need you anymore. And then they started breaking down the equipment and everything. I mean, it was like they scrapped it. It's like,
Yeah.
that's a lot of money right there, because they just realized that it's, the sunken cost fallacy. They were realizing this is not going to work. There's
Maybe,
too many issues with it.
maybe Elon Musk's ultimate genius is that he is not subject to the sunken cost fallacy. So many,
Exactly.
I am. I remember like I was about my sophomore year in college. This is a big one. I was like, physics is not for me, but I'm like, I already devoted 2 years to working on this. I'll finish my degree. Well, I mean, ultimately, in retrospect, probably it was pretty cool to do it. But at the time, I was like, that was not the right decision. It's like move, adjust, do the thing that you want to do right now. So yeah.
Yeah, I mean, it's sort of funny. A lot of people accuse Elon of, not changing his mind and being headstrong. It's like, no, there are plenty of examples where he'll just change his mind
Yeah.
like that once he
Yeah.
sees new data.
Right.
So he was convinced, I think, along with everyone else, that carbon composites is the way to go.
Yeah.
And then suddenly he saw enough data and everything else, and probably enough other people talking about, have you considered stainless steel? Have you looked at that? Looked at that? They finally realized that, no, this makes more sense.
Right.
And part of it is because if you want to produce 1,000 starships, it's a lot easier to do it with stainless steel.
Right.
Even though there seemed to be like, but it's so heavy and this and that, and then you start looking and say, yeah, but it's more heat resistance and all these other things. So when you start looking at everything, it didn't have the disadvantages that everyone expected. And one of the advantages
But
that few
again,
people
there's
would
the
knock them out.
conventional wisdom was like ultra lightweight, moving to super lightweight in carbon fiber. That was the conventional wisdom. That was where everybody was going. And then it's like this
Yeah,
1950s looking rocket. It's like, what? That's crazy. Why would you do that?
yeah.
But
And
yeah.
but carbon fiber is just one of the hardest manufacturing
Right.
processes to be able to get down and to
Yeah.
get it with reliability and everything else.
Ocean Gate. Ocean
Yeah,
Gate.
exactly. I mean, that's the whole thing, is that it's once it starts to fail, there's like almost no way. It's sort of like with your sweater. Once your sweater starts to tear, I mean, that's it. It's like you basically have to stitch the whole sweater together again.
Right.
Um, you just start pulling on that yarn, and it comes undone.
Right.
And whereas with steel, you just kind of go in there with a blowtorch and some a welding torch and kind of heat everything up. But in there, you can heal the whole thing. So maybe that's why in all those science fiction movies, whenever they were repairing their ships, it was always being done with like a welding torch off the side.
Right. So suddenly we're back to the future again. We've got a Cybertruck that looks like some sort of 80s retro, you know,
Hmm.
something from Blade Runner or something. And then we've got the rocket ships that look like 1950s things, but turns out steel is pretty cool after
Yeah,
all.
yeah, it's amazing. It's amazing.
Yeah. So, okay. So we've gone a little off on a tangent, but I still think it's cool to think about this stuff. But so your odds are speculation is that Tesla's working on something very similar to what we were seeing with DeepMind here.
Probably. I mean, that's what we were already speculating, is that they might be going down that route.
Right.
We thought they might have a large language model, and then a few weeks later, Elon kind of confirmed it. Maybe not 100%, but it sounds like it.
Yeah.
And
And I
uh,
think the question in my mind was like, okay, large language model. The question was, is it something that they just plugged onto their architecture, or is it fundamental to the architecture? And I think the answer is starting to look more and more like it's fundamentally part of that architecture, not just a plug-in.
and it
So
may have already been there from FSD,
yeah,
because of the grammar of lanes, that they
yes,
already had something set up like that.
yes, yeah. So there's a good chance, a little shout out to John Emmons, because he might be the guy who's like been behind this stuff since he sort of at least seemed to be the lead for the lane grammar thing. So yeah. Anyway, wow, super cool. Well, thank you so much. I think we've talked about this a lot, but I think this is one of those watch this space kind of deals. Like this is going to be where a lot of improvements are going to be made very quickly. And when people talk about the Chat GPT moment for Tesla full self-driving, maybe it will be kind of literally that. It will be like, oh, it's a large language model inside this thing. So it's like, well, okay.
Mhm.
Yeah. All right. Anything else for everybody? Good.
No, that's it.
All
So
right. That's
hopefully
all we got.
it's nice to know that your mother is doing really quite well. And
Yeah. 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 So she's
yeah,
I just came from the hospital before this, and she's they're talking about dismissing her, getting, or what are they not dismissing? Checking her out, boss.
releasing her. Yes.
Releasing
Yeah.
her from the hospital. And okay, I was like, geez, it's not prison. But anyway, releasing her from the hospital in just a couple of days. So
Well,
absolutely.
that's remarkable. I mean, the fact is like what she was out for 10 minutes and then
Yeah.
came back.
Yeah. Yeah.
And it means you got a person who is not ready to go. So there
Yeah.
was definitely there was like some strong reason she wanted to come back,
Yeah.
and maybe it's like she wants to see Robotaxi in her lifetime.
There you
So
go. That's what it is. Certainly not. I asked her what happened when she was under, and she said she saw me and my brother and my sister. And then I asked her if she saw the white light, and she said no, she didn't. And I was like, well, okay, you're not ready to go to the other side yet. But I didn't ask her if she saw Robotaxi. So I'm going to ask her
right,
that question, and we'll see whether she saw Robotaxi too. Maybe that's what she was waiting for. All right. Thank you so much, Scott. And everybody, remember to do the like and subscribe stuff. Follow Scott on Twitter. It's Going Ballistic 5. Of course, I'll put that in the description, as with the tweet that has this video and the paper as well. So everybody have a wonderful day and get excited about the future. This is pretty cool stuff. Bye-bye. So any clever cold open, or just
oh geez, I haven't thought of any.
right? Need to think of something. Maybe
I don't
we'll
know,
think of
something
something
about
partway through and we can stick stuff it in at the beginning.
something about the I don't know about the Falcon Heavy launch or whatever. It's like,
Yeah, how was that? Was that pretty cool?
yeah, it was forgot how bright it would be,
Mm,
and obviously whatever my settings were that work from 150 miles away don't
right.
work from 10 miles away.
Oh,
So even though
yeah.
the f-stop was like down as small as it should be and everything else, and I wasn't the only one that everything got completely washed out. And maybe if I had tried to shoot a video or take snaps instead, but I tried to do a composite,
Right.
and it's
Right.
like once it's washed out, it's washed out. There's no going back.
No, that one, like when there's too little light with the ones you send me, I can fix that stuff. But that one, I was like, nope, I can't recover that.
Overly saturated, so it's just
It's
like,
just like
oh,
one
okay,
giant block of orange.
it's just gonna make a nice funny meme. But then again, if you look at the webcast, also like the first couple seconds there too, it looked exactly like that.
Yeah.
Just the whole sky was this weird kind of, I don't know, kind of sort of an orange
Right.
yellowish color
Right.
because it was just so intense
Yeah.
that yeah, no one's cameras were able to adjust quick enough to that.
Right. Yeah. Well, and especially because the Falcon Heavy has 3 times the engines too. So even if
Yeah,
you're
you
used
mess
to
it
it
up.
with a regular Falcon launch, it's probably still way brighter than you think. So
And I think what may have made it a little bit worse is the fact that it was just like a little bit of humidity. It wasn't quite foggy. You could still
mm,
see there, but the
mhm,
air was definitely kind of heavy with the
right.
humidity. And that meant it just reflected off of everything there. And so you
Right.
get the scattering all over the place. It just made the whole sky light up.
Right. such such is life. That's the way it goes with.
Yep.
Oh well. They just need to have more Falcon Heavy launches, and then it won't be a problem. Like,
Yeah. Yeah.
it's just,
Exactly. Then we can figure
come
it
on,
out. So
SpaceX. Come on, guys.
yeah.
I think, what did I see that Jupiter, it's something like 29 feet long. It was a beast of a satellite. Like,
Yeah, I think it's what's supposed to be the heaviest commercial satellite put into to
wow.
geo.
Wow.
Uh,
And
but
it was
but it's
still like,
obviously maybe not as heavy because I think the Air Force they launched one earlier,
right. Yeah, but
and
they had to
that one
extend the side boosters on that one.
they expended everything.
Yeah,
Nothing came back home.
right.
And I don't know if that went to Leo or if that also went to Geo. So that must have been quite the heavy beast to be able to get what they needed, or it's like in
Right.
some
Oh,
weird
that's right. And they never tell us
inclination.
what's in there.
Yeah,
It's
yeah.
like, we're
And so
expending
this one they expended the core,
right.
yet they had more than enough margins that they could come home. They could come
Yeah,
back to land rather than having to go out. So to me, it's like, wow, that's amazing. I mean, it still had a little bit more throw weight in there, even though it's one of the largest commercial satellites ever.
right. Now it just goes to show what, just like, that thing is monstrous. And
Yeah,
who knows, with the upside down shower head, hopefully we'll see another Starship launch
yeah,
soon. So,
yeah. The
and that'll
bidet.
just put the Falcon Heavy to shame. So
Yeah. Yeah. It's something else to go out to Playa Linda and you can see the Falcon Heavy sitting out there, and then you see the Mechazilla next to it, and Mechazilla is literally towering over it. It's
Right.
just
Right.
like, wow. And it's like, that's just a beast. Uh,
So how close were you able to get before the launch?
we were able to go out to Playa Linda and get out on the beach. So we were just a couple
Okay.
miles away, and
Oh,
there's
cool.
the problem is how perspective is so weird. The closer you get to something, the more hidden it becomes because
Yes.
the
Yes.
the foreground objects start to get taller and they start
Right.
blocking you. So it was really hard to see all the way down, but you could see where it was. You had to find the right viewing stand, but it clearly got bigger and bigger. And then we met a photographer out there, and we just kind of asked them, wink, wink, if we don't leave the park at 8 o'clock, will they notice? Like, no, they come in here for the Falcon Heavy and for the man launches. They just do a sweep. There is no hiding the bushes or anything like that, hoping you'll be. It's like, no, they make sure you're kicked out at 8 o'clock. For like a normal Falcon 9, they will let you be in the park, and
Oh,
maybe even a little
because
bit
it's
late.
so close to where it lands. It's
Yeah,
they
part of it is that the Falcon Heavy is just so big, and there's
right.
just so many abort scenarios that go on. And with the manned one, I guess if they have to abort, there's like a landing zone that's very close to where Playa Linda Beach is, and they don't want anyone near that because you remember the hypergolics are using a really nasty stuff,
Yeah.
so they really clear it out. They don't even let anyone go over the bridge.
Okay.
So for that, the Falcon Heavy, they were letting people go over the bridge, but I think they were also not letting you get too close. The problem is that the only good viewing spots when you go over the bridge is really in Playa Linda. As you go over it, there's very few places that you can really pull off and get a clear view without there just being palm trees or something blocking it. So I was
Right.
like, if you really want to see it, take off on the pad. Yeah, that's what I decided I want to do this time because I'd already seen the landing. Because a jetty, you can see the landing. Of course, again, you don't see the full landing. You see it just to the treetops, and then it goes
Exactly.
down below that.
But then
And
you
then you
get the
don't see the
toot,
launch.
bang, bang. Like,
Yeah, you get and when you get it down at Jetty Park, I mean, it hits you in the chest. I mean, it's so close that bam. I mean, you really feel it. You notice it out in Titusville, but it's not going to be that intense.
right.
But the problem with also watching it from Jetty is that you have to wait for it to be above the treetops before you actually start to see that it's going up.
Right.
So it's like you know, I'd already been really close to the Falcon Heavy and didn't see it because it was in fog.
Right.
The launch is like, I finally want to see it actually coming off the pad this time. So saw a couple of the others. I think I saw one from here in Sarasota. So that
Okay.
was a really bright streak through the sky. And then the one from Jetty Park where I could say, oh, I actually saw one. And the one in the fog where I had like a half-second glimpse where the clouds just opened enough, just to spit in your face.
Yeah.
It's like it would have almost been better if you didn't see anything. It's just like, oh,
Just a
there it
tease,
goes.
man. It's just a tease.
It
Wow,
just
that's really cool though. And then I saw Glenn. He set himself up by the landing zone, so he got
yeah,
the
he
full
was
effect.
down there.
Yeah.
He had a guest that wanted to see it, and I agree. I mean, it's like not all of them are coming back home.
Yeah.
And so if it's coming back home, the clear decision is you go to Jetty if you've never seen one before.
Yeah. Yeah.
And then because
I
you want to get that
under other
experience.
circumstances in my life, of course, I would have been very happy to have come down there.
Come
But
down either way. Yeah, exactly. Exactly. Yeah. You and Rob Ford have to drag you down.
I know.
He keeps on lamenting that he wants to see one, in reality. It's like, oh, Rob, just jump in the Model 3 and drive down.
We just got to make it happen. I
Yeah.
just drove the wrong direction. I went that way.
Yeah.
Yeah.
Yeah. Yeah.
All right.
Yeah.
Well, cool.
Mhm. So much for cold opens. Yeah.
Yeah, I know, right?
Well,
I was like,
what do we get?
if we put this at the opening of the video, like nobody will watch the rest of it because they'll get
Right,
bored.
right. I said, oh, this is boring. Okay.
Maybe what
So,
I'll do instead is I'll take this and I'll put it at the end as like a little bonus if they want to hear about the Falcon Heavy launch.
oh, okay. Well,
That would
here
be
we
kinda
go,
cool.
John.